Assalamualaikum warahmatullahi wabarakatuh. I would like to say thank you for coming to my presentation. It's great to see you all. Let me introduce myself. My name is Rizky David Kasyanto, student ID number 19,201,038. In this opportunity, this chance, I would like to present about final project entitled Monitoring Tool for Infusion with the Internet of Things using ESP8266-BASED. Background. Number 1. Medical world. In the medical world, infusion is the most frequently used device by patients. Number 2. Infusion device. So far, nurse always check the condition of infusion fluid the patient room and it is still done manually. Number 3. Internet of Things. Can connection of very type device to the internet. The use of IoT technology, the health sector can be applied to several medical equipment in hospitals and health centers. Medical equipment that use IoT technology has advantage compared to ordinary medical equipment because medical equipment equipped with IoT technology can take into account accuracy and efficiency more. It is closely related to the utilization of medical equipment itself, which in this rarely requires accuracy and efficiency. Number 4, it is good that the medical world can monitor the use of intravenous fluid and the condition of infusion fluid via the internet. The formulation of problem. Number 1. How to design a monitoring device for infusion condition using not MCU ESP8266. Number 2. How to design an infusion condition monitoring tool program using an online web-based on not MCU ESP8266 with Arduino IDE programming. Number 3. How does an infusion condition monitoring tool work used and web-based on not MCU ESP8266 with Arduino IDE programming? Scope of problem. This system is designed to detect drip condition, as blood infusion fluid, blood infusion, and dressing to the infusion tube. This tool is built using the not MCU ESP8266 microcontroller and the Arduino IDE programming language. Infrared LED sensor and photodiode to detect the condition of infusion blood. Color sensor to detect blood reaching to the infusion tube. Light sensor to detect blood infusion. The target user are hospitalized patients. Tools. Designing an infusion condition monitoring system. Check the condition of the infusion and adjust the drip rate according to medical standard. Creating a system so that information on infusion condition is more easily accessible via the web online. Send monitoring of infusion condition to be more efficient in accordance with medical standard. Research library. Number 1, research of Yanuar Arif Wicaksono in year 2017 with the title Infusion Monitoring System using load cell based on Atmega 8535 microcontroller and web case study at Bakti Tamtama Hospital Semarang. Number 2, research of Ruslan Abusalim, Adnan Mohneswar in year 2016 with the title Monitoring Infusion Fluid Based on Condition Indicator and Infusion Fluid Rate Using Wi-Fi Network. Number 3, research of Rini Marani, Abdul Muid, Urai Ristian in year 2019 with the title Monitoring and Warming System on Intravenous Fluid Volume Patient using website-based Arduino. Number 4, research of Ismail Halifatullah, Danarius Laksono, Tukadi in year 2019 with the title Design and Build Efficient Monitoring and Control System with Android-based Internet of Things application. Number 5, research of Miftahul Ulum, Ahmad Fifi Gadila, Irfi Nurul Anwar, year 2018 with the title Infusion Monitoring Device with Internet of Things based on Atmega 16 microcontroller. Internet of Things. The thing which we can connect the internet will become Internet of Things. Intravenous fluid infusion, administration of a certain amount of fluid into the body through a needle into a vein to replace lost fluid or nutrition from the body. Not MCU ESP8266. On the Node MCU Wi-Fi module is an interactive firmware based on the LUA expressive SPX1622 Wi-Fi SUC. Node MCU ESPX1266 V0.9 has 4 megabit flash, 11 GPIO pins of which 10 can be used for PWM, 1 pin ADC, 2 pair of UART, 2.4 GHz Wi-Fi and support VPA or VPA2. Air obstacle avoidance sensor module. The air obstacle infrared sensor is a module that functions as an obstacle detector of the object in front of it. The component contained in this sensor consists of an ER emitter and a ER receiver or phototransistor. Arduino IDE. Arduino IDE is a very sophisticated software written using Java. Arduino IDE consists of program editor, compiler, and uploader. Arduino uses its own programming language that resembles the C language. Programs written using the Arduino software are called Sketch. Giant Platform. Giant is an IoT project created for developers, designer, engineers, or students and can be used in a variety of IoT applications. Giant makes the IoT development process easier and faster. Giant itself has a cloud-based web application as well as a mobile application for Android and iOS devices. Website. Website, or better known as the web, can be interpreted as a collection of pages that can display various kinds of the information, data, still or moving image, animation, data, sound, video, or a combination for all of them, both static and dynamic, which form a series of interconnected buildings where each is linked using a network of pages or hyperlink. Research flow. The design of a study is carried out in various stages, starting from searching for literature studies, doing hardware design, designing for software, testing according to parameter, and the last in the stage of making data from the result of system testing. The design uses several hardware and software equipment used to support this research activity. Hardware includes Node MCU ESP8266 function as a microcontroller. Sensor module ER obstacle avoidance serve as a detector of obstacle or object in front of it. Step-down regulator LM2596 serve to lower the PC voltage. Laptop serve to create programming listing, test people, as well as processing data result from system and device testing. Software includes Arduino IDE serve to configure a program that will later be entered into the microcontroller. Giant My Device serve as a database server. Flowchart. From the flowchart image, it describes the steps that can be taken by the program as follows. The first is starting, after that initialization of variable, then the number of infusion drop, then sending data to the server. After that it will plan the reading of the number of infusion drop. If the infusion fluid is less than the minimum limit, yes, it will display a warning that the infusion fluid is running out, and if not, it will return to reading the number of infusion drop. If the infusion fluid does not read, it will display a reading that the infusion is stalled, and if the infusion drip, it will return to the reading of the number of infusion drop. Then the program will be finished. System test scenario. The system testing scenario will explain the monitoring system testing scheme using two tests, namely functionally testing scheme. This test is carried out by testing each part of the tool based on the characteristic and function of each part of the device. Performance testing scheme. This test is conducted to determine the overall performance of the infusion condition monitoring system. Bibliography. E.A. Wicaksono, Infusion Monitoring System using Load Cell based on Atmega 8535 microcontroller and web. Welcome G. Electron and Computing. Vol. 10, number 1, page 12, 2017, etc. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.